Hi, and welcome back to the data science course. This is part one, machine learning and data analytics. In this lecture, we'll cover data wrangling. We've mentioned what is data wrangling, and in the data science process, step five, you saw how and why it's required. And briefly, in other parts of the lecture, we've mentioned that depending on the quality of data, you need to clean it, format it, and there are other activities to be performed. So, what is data wrangling? It is a set of data transformations that have to be performed on the sample data to convert it into a standard format so that it can be used by all your different algorithms. So, uh, it's depending on the quality of data, you may end up spending anything between 20 to 30 or maybe even 40% of your entire data science project's effort on data wrangling. So, just cleaning, formatting, normalizing the data. And it's it's critical because, as you can see, the models are dependent on the quality of the data. So if the data is junk, your outputs will be junk. So you need to make sure that your data is of good quality, it's standardized, and you've performed all the necessary transformations before you pass them to the model building processes, because they are pretty straightforward. Just a few lines of code actually, if you when we show it to you, but it's all the preparation work that comes before it, and a chunk of it is in data wrangling that you need to make sure is pretty accurate. So what we'll do in this lecture is cover some of the more common data transformations. This is not a comprehensive list. I'm sure there are lots or other transformations you can do. If you look at the scikit-learn guide or the pandas or other Python libraries, they'll show you a lot of different transformations you can perform. So we are covering the main ones. So let's look at the first one, which is cleaning. So this is a term you'll commonly hear. We need to clean the data. What is that? Remember again in the data science process, the term EDA was mentioned, which is the exploratory data analysis. So you had an initial look at the data, you understood what the different formats and sources were, and you found some null values, missing values, erroneous data. So immediately you get some idea that, okay, I need to handle this. Maybe I need to replace the missing values with some static value. I need to drop the junk values, or maybe I need to set them to zero. I mean, there are various ways you can do that. So these are called as different strategies. And the most simple strategy is to either drop the entire row or the column with the erroneous data or set it to zero. But there is a possibility it can lead to loss of information. So how do you handle that? Then you try to impute that missing value or the junk data. And there are again various ways you can do that. A simple univariate approach is you replace that missing value by a constant statistic like a mean or a mode, or you try and derive that value using some kind of a multivariate function. For example, you could create a regression function with the other columns in the data, or a k nearest neighbors approach. I mean, there are various strategies. These we would suggest just going to the scikit-learn libraries, see the different strategies, how they work, and apply and learn. I mean, that's the easiest way. But what you will find is generally the more simpler strategies like replacing by a statistic or by filling it with one specific value works much better. And that's what we will be using in our approach. So if you remember the pandas lecture, we'd shown you how to use different functions like forward fill, backfill to fill the missing values with specific data in either a forward strategy or a backward strategy. And you can also use interpolation with different techniques like linear and quadratic. So again, these are best learned by applying. So we leave that for the students. And wherever we are using specific strategies, we will show that in the model building exercises. Another common cleaning technique is to drop the duplicate rows. I mean, that's junk data. You don't need duplicate rows, same data. And this happens quite often, based on the database's quality or the data sourcing, you can have duplicate rows. Uh, Irrelevant data are examples like, so you have one constant value for the entire feature or the independent variable. So that's one column which has one value. It could be something like one city name or one timestamp, and all the rows have that same value. That has of no importance to the modeling exercise. So you can drop those kind of rows or columns as you see fit, because they won't impact the performance of the model. Model can't learn anything from them. So after the cleaning, another important wrangling activity is formatting. So this is like a very common. You'll find data types incorrect. You'll find data within the data type inaccurately written, or they are stored as the incorrect data type. So good examples is date time. So possibly you're sourcing your data from multiple sources, spreadsheets, databases, other files. They all might have a different date time format, but your model, when it takes all the data, you need the date time to be the same for all of them. Otherwise, most likely your model will either throw an error or it'll give you the wrong results. And there are good pandas and scikit-learn library functions which you can use to transform the data very easily from one date time format to another. Similarly, you could have numerics as strings or strings as numerics. And remember, if we showed that to you in pandas and Python also, that sometimes data type could be stored as an object when actually it's a string, and vice versa. So all of these transformations can be done with the help of available libraries. And we'll show that to you when we are building the machine learning models. Then you need to extract useful information sometimes from the same feature. A good example again is date time. So you might have the entire date in one column, but you might need the year, month, and day separately to perform some aggregation functions for some time series analysis. So that is one reason you might need to split one particular feature or independent variable into separate features, and you can do the same vice versa, right? So you might need to combine different columns into one column. So multiple features combined into one feature, because as separate features, they are not that useful. But when you combine them, you get more useful information. So you'll find that throughout the code, you will probably see examples of this too. So a lot of these things will depend on the data that you have. So it's not necessary that you have to do these wrangling activities. If the data quality is good and you don't need to do any splitting or aggregating, then great. I mean, you need to spend less time on the entire data wrangling process. Okay, so another very useful data wrangling activity is the encoding of categorical data. And you might have understood that categorical data is basically data which is in the form of categories. Remember, we mentioned that machine learning models work with numbers. So if you pass text in a particular feature or independent variable, the model will throw an error. So how do you convert these categories, which are most likely text, into numbers? To do that, we'll use a technique called as one-hot encoding. What it does, it converts your categories into a binary matrix of n categories called as dummy variables. But before doing that, let's understand why you need to do this. So assume you had multiple categories in one column, and you assign them a sequence number of 1, 2, 3, 4, 5 instead of their textual word. Now, what could happen is the model might think that the category with the higher number is more important. Remember, we mentioned about this concept of standardizing the data because some of the models are distance based. So you want to avoid that inaccuracy. So you want to treat each category equivalently. And hence, instead of giving it a sequence number, you create a binary matrix, which is basically zeros and ones. So what it does, it converts the categories into columns. And when one category is present, it gives a 1 in that row, and all the other columns in that row are 0. And when the next category appears, it assigns a 1 to the column assigned to that category as 1, and the rest are 0. And then this is repeated for the entire data set. So you'll get a nice little grid matrix, and it's sparse because it's got lots of zeros and just ones wherever the specific category is. We will show you this with the help of an example. Um, and there's something called as a dummy variable trap that happens within that. Now, since you've converted these categories into zeros and ones, what can happen is that you can end up getting a highly correlated data. And that's because of the sequence of ones and zeros and how the model interprets that. So example is male and female. You give 0 to one and 1 to the other. And if you give two columns, so there'll be either a 0 in one column and 1 in the other, and vice versa for all the different rows. And the model might end up using those two columns as more important because they're highly correlated. We don't know that. So to avoid something like that, you drop one of the columns and just use one. So wherever it's 0, we assume that's a female. And wherever it's 1, we know that that's where the male occurrence is. Right? So you've removed unnecessary data and you've reduced the correlation between two columns. So we'll use the one-hot encoder sklearn library to do this. It's popularly called as one of k. Another useful data wrangling activity is binning. So you're trying to partition your continuous data into discrete values. Remember, categories and bins, if you remember our statistics lecture, histograms, you split your distribution into groups, ranges, buckets. So 100 marks were divided into bins or buckets of 10. Now, if imagine if we had real-time data coming through from different applications, you're probably getting a huge stream of continuous data, and it's going to become very difficult to analyze that. So that's when the concept of binning, which is also called as discretization, quantization, bucketing, basically you are creating bins and buckets or categories. That's when it becomes important, and it allows you to overcome this skewness in the data. Now, partitioning it into different categories is made easier by using sklearn's libraries like Kbin's discretizer, and you can apply various strategies. Constant width bins by uniform strategy, and then you can use the quantiles. So again, remembering the statistics lecture, we discussed quartiles, which split your data into 25% buckets. You can plot them using box plots. You can create 10% buckets. So that's the quantile strategies. I mean, there are various ways you can do that, and you can use the libraries to easily handle this transformation. Aggregation, again, we covered. If you remember in pandas, we showed you how to group by an aggregate and then perform group level statistics. Again, large data sets, continuous data sets, you want to analyze them at a more higher level. So it's better to calculate some aggregate statistic like a mean or a standard deviation. So if you have daily data, you might want to aggregate that into monthly mean or standard dev, so that when you pass this data to the model, it can make more useful conclusions uh, than just looking at the entire data series. And here, quite often, it'll depend again on the data size and the data set you have. And just to remember that whenever you're doing these transformations like aggregations, make sure that you don't lose the relevant information. So be careful there. And I think you can make that judgment call once you start building the different models with different types of data sets. And another benefit of aggregation is, of course, is you're reducing the random noise, right? So if you're converting from daily to monthly, most likely those daily variations are sometimes noise. You don't need that. And again, merging, joining of different data sets. Look, you'll be downloading data from multiple sources, convert them into data frames, then merge them all into one data frame because your all the data needs to be passed to the machine learning model. So again, we'll show you this while doing the model building exercises. And as examples, we've already shown you in pandas how to merge or join different data frames. So overall, if you think about data wrangling, you'll find that between Python, pandas, and NumPy, you can perform majority of the data transformations that you need to perform. And then combining that with scikit-learn's libraries, you'll see that you can handle most of the variations that you need to handle in data wrangling. Now let's look at the Python example to understand some of the data wrangling activities. It's a simple example, so it'll show you some of the basic wrangling activities, but a large number of them will be covered more comprehensively when we are building the models and the end-to-end project. So we'll just import a simple data set which you've already seen in one of the examples in Panda's lecture. And if you look at the data, it's again some US stock indices, some commodity prices. It's a time series data. You'll find that there is some junk and missing values. So we'll perform some data transformations to clean and format the data. So let's look at a simple example to see why we might need to perform these formatting and cleaning activities. What we are trying to do now is just combine the two index values in the two separate columns. We expect them to be numeric, and as part of an algorithm, maybe you want to add them up and do something with them. So we'll just execute this, and it's giving us an error. Why is that? So let's check the data types. Great. So what we see is that the S&P 500 data is stored as a float, but the Wilshire real estate index is stored as an object, and you can't add them up. So now you need to convert the object data type to an integer or a float. So we'll convert it to a float. Now we know that in a data frame, you can set it as a type by using the astype function. So let's try that. But that's giving us another error. So thing you have to remember is when you're applying a function like this to the entire data frame, it expects the data to be in a certain format. Now the problem you're facing here is if you open the data frame, you'll see that the NASDAQ has got a comma in this numeric value, which is possible, and it's stored as an object. So it doesn't recognize the fact that it's numeric. It's treating it as a string. But now you're converting that string to a numeric value, and you got a comma there. So that won't work. So what you have to do then is to replace that comma. Now the way this replace function works, it works at the series level. So you have to extract the column and apply it to that. So let's do that. Great, we've completed that. Now if you see your NASDAQ column, the comma is gone, but the integrity of the data is maintained. Let's try to do the astype function again, and then you get another error. Okay, so you can. I think you can start seeing the flow here. You've got multiple errors in the data. So there's a dollar stored somewhere in the numeric text. Oh, there it is. So again, that's junk data, and again, based on the strategy you want to pursue, you can do different things there. So we'll just replace that also with a blank. So we apply that. Ignore the warnings for now. We'll teach you how to ignore them. This happens quite often because of different versions in the software libraries. So now if you look at the data, that dollar is gone and there is a blank space there. Okay, just to be more elaborate here, let's try to do the as type again. And again, it's given us an error. Now the problem is that you've replaced the comma or some of the erroneous data with a blank space character. Now again, you're trying to convert that to a float. So the function call is returning an error because you can't convert that string character to a float. So the safer and easier way to do is to use the pandas to numeric function. What it does, it overcomes all these issues and converts the data to the type numeric. So now if I run this and check the data type again, you'll see that your NASDAQ is a float. So you have to remember that it's not a straightforward data transformation. You can't just convert the entire data frame at one go, depending on the issues in the data, depending on the individual types of the columns or the independent variables. You need to perform different transformations. And what you can do is convert a lot of these transformations into methods, functions, so that they can be called and applied to different columns or independent variables as required. So we'll show you that in the model building exercises. Similarly, now let's look at the other column in the data frame, Wilshire RE. First, let's check if there are any issues with that column. So again, what we'll do is try and convert the data type for the entire data frame. And if you do that, again, you're getting an error. And it shows you some junk data like CC. Now, where is that? You can straight away see. I mean, look, so this is a very small sample data set. This was to show you the data wrangling activities, but imagine if you had a very large data set, then it would not be that straightforward to search and replace these. So you can use some slightly more complex and useful functionalities like regex using the same functions, and you can transform the data. So here we know that we have to replace all these junk CC values. So we'll replace that with again a blank character. We do that and we'll not repeat it, but what we'll do is now we'll also convert our column to numeric. So if you now check your data type for the data frame, you see all these objects were converted into floats. Now there is still one more data frame which you can see is the date type, and it's being read as an object. Why is that? See, quite often the data when you load it, it doesn't instantly recognize the data type. It could be because of the junk data or the data type it is. And date is one data value where you face this issue. So generally it will be imported as a object and you need to do some conversion transformation on it. So you can see here your date is in the date format, but it's still recognizing that as an object, maybe because of some erroneous values like you can see here. If this is day month here, they've been confused up here, or any other values could have been erroneous. So the easiest way to handle that is to use the date time functionality in pandas. Convert your column for that data into a date time data type, and you can specify formatting parameters like the actual format, both for the input or the output, or just a simple one like day first is true, which means the first value in your input data is the day. And once you do that, uh, let's run it. And what you'll see, well, let's first see the data type. We'll show you the data too. Your date column has been converted into a date time data type. And if you look at the data, you see this. It's a fully formatted date time uh, data type with the timestamp. And one of the other useful things here is it's actually handled the mix-up between the month and the day because you specified the correct day start. Uh, let's look at this data again. So you see these nans. So again, now just a few of them. So do you really want to drop the entire row? Probably not, because that's useful information. Maybe you want to do these strategies like giving some mean value for this column or standard dev or some other strategy. Or maybe you just want to do the basic simple strategy of replacing them with zero and let the model handle it. So what we generally end up doing is you fill these nans or non-numbers with zeros, and you can always change the strategy based on the results you get. So you run that on the data frame. You know the concept of the in place is true, so it updates the data frame, and now all your nans have been replaced with zeros. So these are some of the simplest examples we've shown you here to understand how to handle some basic data wrangling activities. They can get quite complex, and we'll cover some of that when we are building the models. And the next example is we want to show you is how to handle categorical data with the help of one hot encoder. So let's just load some simple data, and we've used the sklearn's one hot encoder library for this. So now your data is just the names of cities. So it's one column, just a simple example. I mean, this column could be part of your entire data frame. So it has to be in the entire series of transformations which you do. Again, covered in the model building exercises as part of the pipeline activities. So this is the name of the city. Now we want to use this data, but the text is of no use to us. I mean, the model will reject it. So we need to convert it into numbers. And you can see some of the cities are repeating, right? And if you remember, we already told you that you don't want to give them a simple sequence number like the index. That's not the right approach. So we create the binary matrix using dummy variables zeros and ones. So you transform these rows of city names into columns, and they'll have zeros and ones depending on where the occurrence of that particular city name is. And I mean, it's you can see the output by printing, and so we'll make a call to the one hot encoder class, create the object, ignore the unknown errors, and fit the data. Remember, we mentioned in the data science process some of the terminology for sklearn libraries. We had the fit and predict methods. So we have a fit and a transform method. So what the fit does, it fits the data into the model, and then transform is when you apply the transformation. That's the data transformation. So took the data, fit the model to it, which is the one hot encoder, and then it applies the one hot encoder transformation. So you need to call that as part of the transform method call. So to simplify this, it actually has another function called as fit transform, which does both activities at the same time. So you could use that. We are running it separately to show you the actual methods, and let's now run that. So we'll call the one hot encoder method and fit the data. So it's created that object, and now we transform the data, which is our data frame, and we convert it to an array to view the data. You can transform that into other data structures to be absorbed into your entire data frame after the transformation. So you do that. So now do you see this? So if you just check here, like, you have these cities, there were 10 rows, and if you count them, you have 1, 2, 3, 4, 5, 6, 7. You have 7 cities, so you've got 7 columns, and you've got all the 10 rows. And now in each row, you only see one in one particular column. So San Francisco was column number 5. Then London was column number 1. So London is present in this row, so it'll put 1 there and all the other values are 0. So if you see London is repeated in row 4, so you see the same value in column 1. So you've got 1 there and zeros in the other columns, yeah, right? So you've transformed your textual categories into a column of binary data of zeros and ones. And then you can add this back to your data frame and then pass it to the machine learning model. Okay, so in conclusion, what happens with all this data wrangling is that you end up creating a standard data which can then be used by all the different machine learning models that you're trying to build. So this is a critical activity, one-off effort, takes time, but once you do it, it makes your life much more easier to build the data science models. So hopefully this lecture has taught you how to perform all the different data wrangling activities, to format, to clean, to encode, and to bin and aggregate the data. And what you'll see in the future courses is that as we start building the machine learning models and we show you the end-to-end projects, we'll show you in a very comprehensive and in a more uh, connected way uh, why these data wrangling operations are performed and what are the different ways to do it. So with the end of this lecture, you've actually covered most of the basic foundations you need to build machine learning models. And I know you must be eagerly waiting to build the models. I can assure you, while it is very easy to do it programmatically, just a few lines of code actually. But even there, you need to learn the different models. But to get to that point, you needed to learn some basic programming and analytic libraries, Python, pandas, learn the math, stats, probability, understand the data science process, how to solve the problem, how to select the algorithms, how to select the best model, and then how to visualize it and deploy it. And finally, here in the data wrangling lecture, we've covered how to prepare that data so that you can now build the machine learning models in a far more easier way. So we'll now move to the next lecture series, which is about regression. Thank you for joining the course, and now we'll see you in the next lecture. Thank you.